Adjunct Professor Moran, Macroeconomics 111. We did a lot in this unit on aggregate expense model, also known as the Keynesian model. This is going to be our review sheet. We're going to put it all together. We're going to develop each one of the four variables: consumption, business spending, government, imports and exports. We're going to consolidate them. That's going to give us our actual level of output. We're going to compare that to the full employment level of output, determine whether we have a recession or an inflationary period. Then the government is going to solve this and restore us to full employment through the use of multipliers. As underpaid but dedicated government economists, we will analyze the current state of the economy by each component of aggregate expenditures. We'll compare the resulting actual GDP to full employment GDP. If a recession exists, we'll recommend to the President an increase in government spending, reduce taxes, or both. That's expansionary fiscal policy. If inflation exists, we'll recommend to the President that the government reduce its spending, increase its taxes, or both. That's contractionary policy. If the goal is to restore the economy from the equilibrium resulting in recession or inflation to an equilibrium that results in GDP full employment with price stability, that's our goal. We need to determine our current economic condition. We're going to develop consumption first. Our economy consists of four different consumers listed below. For each, determine the missing consumption or savings. Then calculate the average and average propensity to consume, average propensity to save, marginal propensity to consume, and marginal propensity to save. We're going to do the average just to show that average is not marginal and that we're not going to use average. If disposable income is 20, but someone's spending 21, they are dissaving 1. If someone income is 30 and they're saving 0, then they're consuming 30. If someone's income is 40 and they're consuming 39, then savings is 1,000. There are only two things you do with your disposable income: consume it or save it. If someone's disposable income is 50 and they're saving 2, then they are consuming 48. Averages are a snapshot in time. All the information for an average will be taken from one line. A marginal is a change. Marginal means change or next, and it's a change in time, so the information will come from two separate lines. So, for example, the average propensity to consume, you'll take the consumption number and divide it by income. And 21 divided by 20 gives you an average propensity to consume of 105%. 30 divided by 30 will give you an average propensity to consume of 100%. 39 divided by 40 gives you an average propensity to consume of 98%. And 48 divided by 50 is an average propensity to consume of 96. You can see that the average propensity to consume changes based on your income. This is not going to be helpful for us as economists when we give a tax cut or increase government spending and we're trying to predict how much people are going to spend of that extra income. The average propensity to save can be found two ways. 100, you only have 100% of something, so 100 minus 105 is minus 5%. Or you can take savings and divide it by income. So 1,000 divided by 20 is minus 5%. 0%, 2%, and 4%. We're not going to use these numbers. We're going to use marginal numbers. And this is the symbol for change. Change in consumption divided by change in disposable income. In order to get a change, you have to compare two different numbers. So, change in consumption divided by change in disposable income. When income changes by 10, consumption is changing by 9. So the average propensity to consume, the marginal propensity to consume, will be 0.9. That's true for any point that you use, because this is a straight line, and the slope of a straight line will be equal. When income changes by 10, consumption changes by 9, 0.9. What's the marginal propensity to save? When income changes by 10, savings is changing by 1, 0.1. There's only two things you can do with an extra dollar: spend it or save it. In this example, this person would be spending 90 cents of every extra dollar they earned, and they'd be saving a dime out of that extra dollar. What's our total income in this society? 20, 30, 40, 50 sums to 140. What's total consumption? 21, 30, 39, 48. Total consumption is 138. What's savings? Minus negative 1, 1 is 0, we have 2. Or total income minus total consumption is savings. What's the total level of consumption? Our first level of aggregate expenditures in the economy, 138. What's the total level of savings? 2. I'm drawing your attention to this because of something that we're going to develop next. And it's important that you see this is equal to the next variable at equilibrium. We're now going to develop gross private domestic investment, IG, business spending. Here are various interest rates, and here's the corresponding amount of investment that will happen. At high interest rates, the cost of borrowing is high, and so fewer projects become profitable, so there'll be less business spending. But at lower interest rates, the cost of borrowing is reduced, so more projects will be profitable and businesses will borrow more to undertake new projects. We're going to sketch the investment schedule. We're going to try to explain business spending in dollars with interest rates as a percent, and it's a negative relationship. The demand for new business spending is a negative relationship between how much is spent and interest rates. At 10%, there'll be only a small amount of business spending. 7.5%. There'll be 1,000. At 5%. There'll be 2,000. And at 2.5%, there'll be 4,000. To review what I did, I'm going to take, at a high rate of interest, there'll be relatively little new business spending. At a low rate of interest, there'll be a higher rate of business spending because costs are less. So more projects will be profitable. I'm going to graph this. 10% and 500. 10% and 500. 7.5% and 1,000. 7.5%, go over to the IG line, 1,000. 5%, 2,000. 5%, 2,000. And 2.5% business spending through borrowing on new projects will be 4,000. 2.5, 4,000. Now, we're going to assume that the actual rate of interest in our economy is 5%. At 5%, businesses will borrow 2,000. How much will businesses seek to borrow for gross investment purposes? This is the second component of aggregate expenditures, 2,000. By the way, how much was savings? Savings by consumers was 2,000. At equilibrium, savings will equal business investment. You take some money to the bank, they go and borrow it. Savings is a leakage in the Keynesian model. In other words, if we have 140 in income, factors of production earned 140 by producing an expense approach amount of output of 140. But if you save 2, then there's only 138 available from income to buy output, and 2 will go unsold. That will lead to layoffs and a permanent recession. However, at equilibrium, business spending will also be borrowing 2 and spending that 2, and that plugs the leak. Now we can develop government spending, the third variable in our aggregate expense model. It's assumed that government spending is independent of changes in GDP. So government spending will be a constant amount of 5. Now, let me go back here. When we discovered that business spending was 2, it will also be a constant amount. So we're assuming that business spending is not going to change with levels of GDP, a somewhat unrealistic assumption, but a simplifying assumption. Government spending is going to be independent of GDP. We're now going to develop our last variable. Let's say exports are 2 and imports are 1. That would give us a trade surplus of 1. Now, when we do this ordinarily, this is going to be 0, because this is now an injection into our economy. So I'm just doing this to demonstrate what a trade surplus would be. If they were reversed, there'd be a trade deficit. But really in the Keynesian model, you want to have this 1 and 1, and this 0, so there's no leakages or injections. We can now find out what our current level of aggregate expense is. We're going to go back to the first page and get consumption, 138. We're going to get gross private domestic investment, which was 2. We're going to get government spending, which was 5. We're going to get net exports, which we were assuming was a trade surplus of 1, right here. We're going to add that up, and we are going to get 146. Notice that our level of consumption is not the same as break-even. Break-even happens at 30. Our total level of consumption is the sum of all consumers, not just those breaking even at 138. Now we're going to consolidate our variables. Here's consumption, 138. Now we're going to add 2 for business spending. This is 2 higher. We're now going to add government. C plus IG plus G. This is 5 higher. We're going to add our last variable, C plus IG plus G plus XN. This is 1 higher. This is aggregate expenditures. So you don't have to write these anymore. And you don't show them like that. I'm just showing you how we developed the aggregate expense line by developing C, business spending, government spending, XN, add them all together, and now we have an aggregate expense curve with an actual equilibrium of 146. We don't know whether that's inflationary or recessionary because we have to determine what the full employment level of output is. Here's GDP actual. We just developed it. The table is telling us that full employment happens at GDP output of 121. We're going to put those on the graph. I'm going to write 2 lines. 121 comes first. 146 comes second. So this would be GDP, full employment, and this is GDP actual. This is aggregate expenditures actual. This is aggregate expenditures full employment. Since actual is exceeding full employment, this distance here is an inflationary gap. This would be unemployment, for example, of 4%. Since this is higher level of output, to produce that, you would need more workers, and that would drive unemployment down to maybe 3%. The unemployment would be too low. What is the inflationary or recessionary gap? If we go from this point, which is 121 and 121, and go up to this point, that will be 123.5. The recessionary gap is 2.5. In other words, the government's going to have to try to lower this line by 2.5 from here, but it actually, you measure it here, but you go from here to here. This is 146, 146. If the government can reduce this by 2.5 to 143.5, then there'll be a disequilibrium. And since we're on this side of the curve, making an output measure, also an income measure, will be greater than what's on this axis, which is going to be buying. Inventories will increase, which is bad because businesses aren't selling all the output they thought they were, and they'll lay workers off. Output will fall, income will fall. When income falls, consumption falls, and that will walk down this line back to an equilibrium. Assuming the government wanted to restore the economy to full employment, it should, well, in an inflationary period, it's going to want to increase taxes. Personal income minus taxes is disposable income. Increasing taxes cause disposable income to fall. which would cause both consumption to fall and savings to fall, and we'll drop that line on top of this one. Or it could decrease spending. Government spending is another component, so they could do it by reducing consumption or government spending. There are three ways the government can accomplish this goal. They can use spending, they could change taxes, or they could use a balanced budget multiplier. By how much should the government increase or decrease spending? What's the marginal propensity? We calculated that on the first page. The marginal propensity to consume is 0.9. What's the multiplier? The multiplier, the spending multiplier, is 1 over the marginal propensity to save. What is the marginal propensity to save? 1 minus 0.9 equals 0.1. Or you can calculate it by finding the change in savings divided by the change in income, 0.1, 2 ways. That means that the multiplier, 1 over 0.1, will be 10. Any change in government spending of 1 will cause a change in GDP of 10. What is the recessionary gap? Okay, now don't get confused. This is an inflationary gap. What I'm asking for here is how much do we need GDP to change by? We need GDP to change by 25. 146 minus 121. Okay, what's the gap? I'm sorry. This is 2.5. There's the gap. If the government changes its spending by the amount of the gap, what will be the change to GDP? The formula you want to use is change in GDP equals change in aggregate expenditures, in this case the government, times the spending multiplier. So we can do this two ways. We'll do it the way the question asks first. If the government changes spending by 2.5 and the multiplier is 10, then GDP will change by 25. Notice that the amount of the gap will result in a change in GDP that we desire to return us to full employment. The way that you really should do this is change in GDP equals change in aggregate expenditures times the spending multiplier. We know that we want GDP to change by 25. We need to solve for how much the government needs to change spending to restore us to full employment, and we know the multiplier is 10. Divide both sides of the equation, this side, the right side and the left side, by 10, and you get 2.5 equals the change in aggregate expenditures. So the government would reduce spending by 10, causing a disequilibrium, where making would be larger than buying, businesses would produce less, lay workers off, income would go down, and you'd ride along this line back to equilibrium. What was the discrepancy in the amount of goods and services? 25. After the government changes spending, what's the difference between actual and full employment? Nothing. The government just restored the economy to full employment and eliminated the inflationary gap. The government can accomplish this by doing a change in taxes as well. So, what's the marginal propensity to consume? As we did in the last problem, 0.9. What's the marginal propensity to save? 0.1. The tax multiplier is a negative marginal propensity to consume divided by a marginal propensity to save. Negative 0.9 divided by 0.1 equals a negative 9. Notice that the tax multiplier will always be 1 less than the spending multiplier and a negative. The spending multiplier is 10, the tax multiplier is 9. That's because a change in spending by the government counts as it is included in GDP immediately. A change in taxes, though, is a change in income. It's a transfer payment, which does not immediately affect GDP. Part of that will be consumed and part will be saved. Savings is a leakage that does not contribute to the GDP amount. So this will always be less by a factor of 1. What is the recessionary gap? 2.5. Multiply the tax multiplier by the gap. .5 times 9 is 22.5. What's the difference between actual and full GDP? 25. So we reduce GDP by increasing taxes. We reduce GDP by 22.5. But we needed a change in GDP of 25. Why didn't this restore the economy to full employment? We're 2.5 short. Well, again, as I said, the change in government spending with the spending multiplier counts 100%. But here, the change in taxes does not count because it's a transfer payment. So the difference between 10 and 1 is the factor of the gap of 2.5. We're 2.5 short. That was the gap. It works out because there's a change in the two multipliers of 1. How much would the tax cut have to be to restore the economy to full employment? So we go back to our formula. Change in GDP equals change in taxes times the tax multiplier. The change in GDP we desire is 25. We're going to solve for the change in taxes necessary, and the tax multiplier is a -9. We're going to take 25 and divide it by 9. And we get 2.8. We're going to have a tax increase of 2.8 to cause aggregate expenditures to fall enough to restore us to full employment. The change in taxes will have to be larger than the change in government spending because the first round of a tax cut is a transfer payment and not included in gross domestic product. Finally, the last method that the government could have to restore us to full employment would be the balanced budget multiplier. This would only result if the Congress passed a balanced budget amendment to the Constitution requiring the government to match changes in spending with changes in taxes. This is shown for demonstration purposes only. The government will not do this because it would handcuff the government's ability to manage the economy, because the entire amount of the shortfall in GDP or surplus in GDP would have to be reduced, which is often $1 trillion or more dollars. It would not be practical. But it's an extreme, and you should be aware when people propose a balanced budget what it means in terms of the government managing the economy. The gap is 2.5. Multiply the balanced budget multiplier by the gap. The balanced budget multiplier is always 1, 2.5. We would be 22.5 short of GDP, of restoring GDP to full employment, because, and why didn't this restore it? Because in order to have a balanced budget multiplier, if we drop G to fight inflation, by law, the balanced budget amendment would say we'd have to decrease taxes. The decrease in government spending is contractionary, meant to fight inflation, but the decrease in taxes is expansionary, and that would be meant to fight a recession. They don't cancel each other out completely because the government spending multiplier is 10 and the tax multiplier is 9, leaving an effect of 1. And that's why you'd have to take the shortfall in GDP of 25, multiply it by that multiplier to restore the economy to full employment. In the next video, we're going to study a recessionary gap.